Today's lesson, we're going to talk about trigonometric equation, solving equations. In order to do that, we need to memorize the table or have this information so we can get the value. Let's try example 1a. These problems, you have cosine x equals to square root of 3 over 2 on 0 to 360 degree. So they want to find the angle between one circle, right? And you wanted to solve this unknown variable. It means you wanted to get rid of cosine. In order to get rid of cosine like this, you're going to multiply both sides by cosine inverse. So you do that on both sides. Cosine inverse multiplying. That cancels out cosine inverse with cosine. You will only leave you x on the left side. You have cosine inverse of square root of 3 over 2. And from this information you have, you wanted to find which angle gives you cosine square root of 3 over 2. Cosine square root of 3 over 2, that's going to be 30 degree. So then this is going to be 30 degree. And remember, it's between 0 to 360 degree. So from the whole one circle, right? So from the having a 4 quadrants, which quadrant will give you positive cosine value? That's going to be first and fourth quadrants. These two quadrants, your cosine is going to be positive, right? It will be positive, and negative, positive, and that's negative, and this is going to be positive and negative. And since cosine is x value, this two quadrant, your cosine will be positive, and this value right here is positive. So it should be on the first quadrant or fourth quadrant of 30 degree. So you could say 30 degree in first quadrant or 30 degree in fourth quadrant. That's your x values. 30 degree in first quadrant will be just 30 degree. 30 degree in fourth quadrant, you do 360 minus 30. So you get 330 degree. So that will be x value. The way that you can write your solutions, if you're looking for between one unit circle, then you could just say 30 degree and 330 degree. But let's say if you didn't have any limits, then you could also say 30 degree plus 360 degree K. And 330 degree plus 360 K. What does that mean? Well, if we're looking at the solutions where you're going to have 30 degree right here, so it could be either, in order to be this point right here, it could be 30 degree, but it could also be going one circle and then go 30 degree more. So in that case, will be 360 degree plus 30 degree, right? You can also do, instead of one circle, you can do 2 circle and 30 degree more. 3 circle and 30 degree more. That's how you get K rotations. So it depends on how your solution is asked. If it's in between one circle, this is going to be fine. If they don't give you the limits, this is how you're going to write your solutions. Let's look at the example 2. Remember from the other example, I said that you wanted to isolate x by itself. So in order to do that, you probably need to get rid of this first multiplication, which is -2 times, and then you wanted to get rid of sign by multiplying both sides by sine inverse. So let's do one at a time. You're going to divide both sides by -2. Then you get sine x equals to -1/2. And then when you multiply both sides by sine inverse to get rid of sine, you will get x equals to sine inverse of -1/2. Now we're going to see which angle will give you sine -1/2. Well, just find the numbers 1/2. So sine 1/2, that will be 1/2, which is 30 degrees again. So then it's going to be 30 degrees. And this is negative. So remember from rectangular coordinate systems, where is the sign negative? Sign negative, sign is y value. Y negative is third quadrant or fourth quadrant, right? If you look at the sign that I wrote it from the previous example, your y value is negative on a third quadrant and fourth quadrant. So you will say 30 degrees in third quadrant and fourth quadrant. That's going to be negative. In order to find 30 degrees in third quadrant, you do 180 plus 30 degrees, which is going to be 210. In order to find 30 degrees in fourth quadrant, you do 360 minus 30. So that gives you 330 degrees. So that's how you can find your solutions if you have a limit. Had to be between 0 to 360. But again, if that limit wasn't given, you also need to say 210 degrees plus 360k, or 330 degrees plus 360k. Let's look at example C. So remember from the second problem, what I wanted to do, these types of problems, I wanted to isolate x. This time you also have additions and multiplications, and you wanted to get rid of addition first. So you're going to subtract square root of 2 from both sides. You get 2 cosine x equals to negative square root of 2. And then divide both sides by 2. That gives you cosine x equals to negative square root of 2 over 2. And multiply both sides by cosine inverse to isolate or get rid of cosine. You get x is equals to cosine inverse of this value. But then don't forget, this numerator inside of square root 2 and denominator 2 is same. It means this has been rationalized. So before rationalized, this should be 1 over square root of 2. And when you go back from the angle and see which one gives you 1 over square root of 2 in a cosine, that's going to be 45 degrees, but they want you to talk about as radians, so it will be pi over 4. So that gives you pi over 4. Pi over 4 negative. This is negative value. So where is a cosine negative? So cosine negative, cosine is x, And x negative is second quadrants and third quadrants. So that's going to be pi over 4 in second quadrants and third quadrants. Second quadrants, you do pi minus pi over 4. Third quadrant, you do pi plus pi over 4. That gives you pi is 4 over 4, so it will be 3 pi over 4. That's another 4 over 4 plus 1 will be 5 pi over 4. And that value right here is in between one unit circle, 0 to 2 pi. Again, if that wasn't there, then you need to do 3 pi over 4 plus 360 is same as 2 pi, so 1 unit rotations, right? And then 5 pi over 4 plus 2 pi k. What about next one? This time you have a square. What do we do when we have a square on the equations? We use square root to get rid of square. So we're going to do the same thing here. So first thing I wanted to do is square root both sides to get rid of square. So when you square root both sides, don't forget you need to put plus minus sign on the other side. That cancels out square. So you have cosine x equal plus minus square root of 3 over 4, which is going to be same as plus minus square root of 3 over 2, right? And when you multiply cosine inverse, it will give on the other side cosine inverse with plus minus square root of 3 over 2 value. Plus minus, it means it will be coming from all 4 quadrants. And which angle gives you cosine of square root of 3 over 2? Well, that's going to be 30 degrees, which is pi over 6. So pi over 6 in all 4 quadrants. So it will be first quadrant, second quadrant, third, and fourth. First quadrant is going to be just pi over 6. Second quadrant will be pi minus pi over 6. Third quadrant, pi plus pi over 6. Fourth quadrant is 2 pi minus pi over 6, which is pi over 6. That's 6 minus 1, so it will be 5. 6 plus 1, 7. And 12 minus 1, so it will be 11 pi over 6. So if you're only looking for the solution from in one unit circle, that should be the solutions. This time, example 2, you have double angle, right? What do we do if we have double angle or more than one angle? So the first thing we wanted to do is, well, trying to isolate. What are we looking for? We're looking for theta right here, right? Theta. So we wanted to get rid of everything one at a time. So let's get rid of cosine by multiply both sides by cosine inverse. Then you get 2 theta equals 2 cosine inverse of 1/2. And we wanted to look at the degree. So 2 theta is going to be, which angle gives you cosine 1 over 2? That's going to be 60 degrees. Positive cosine cosine positive, x positive is this side, right? So it will be first quadrants and second quadrants. I mean fourth quadrants, right? And if we wanted to get that in a number, it's going to be 60 degrees. And 360 minus 60, so it will be 300. But then that's what 2 theta is. 2 times the angle you're looking for is that value. So now if you wanted to do isolate theta. And before we do that, because we're going to order to isolate theta, you're going to divide both sides by 2. So we wanted to make sure we add the unit circles to it. Different rotations, right? That's one case, and 2 theta equals to 300 degree plus 360K will be the second options, right? In our fourth quadrant. And now isolate theta by dividing both sides of equation by 2 on both solutions. Then you get theta is equals to 30 degree plus 180 degree K. And same thing on this one, it will be 300 divided by 2, so it will be 150 degree plus 180 degree K. And this will give you 30 degree. So when K is 0, right, it will be just 30 degree. This one, when K is 0, will be 150. When K is 1, it will be 180 plus 30, so it will be 210. And 180 plus 150, you get 330 degree. And if rotation, one more rotation, it's going to make it above 360 degrees. So we stop here. And that will be the solution angle. We're going to try one more time. So what do we do first? We wanted to isolate or get rid of sine by multiply both sides by sine inverse. Then we get 2 theta remaining on the left side, and we will have sine inverse of negative square root of 3 over 2 remains on the right side. And we know that square root of 3 over 2 as a sine, you're going to get pi over 3. And being negative signs, sine is negative, y is negative in third quadrant and fourth quadrant. So 2 theta equals to pi over 3 in third quadrant and fourth quadrant. That gives you third quadrant is going to be pi plus pi over 3, which is 4 pi over 3 plus 2 pi k. And when in the fourth quadrant, it will be 2 pi minus pi over 3. 2 pi minus pi over 3, you're going to get 6 pi minus pi over 3, right? So that's going to be 5 pi over 3 plus 2 pi k. And when you divide both sides by 2 to isolate theta by itself, you get that will be 4 pi over, you're dividing by 2, so this is going to get doubles. 3 times 2, so it will be 6, right? plus divide by 2, cancel out 2, so it will be pi k. Same thing on this one, divide by 2, that becomes 5 pi over 6 plus pi k, right? Don't forget this is what I'm doing, dividing by 2 on both sides of equations. So your solution should be, in a first rotation, no rotations, that will be just 4 pi over 3. I mean 6, right? 4 pi over 6. In my head, I was reducing, so that's why I say 3, which is going to be 2 pi over 3, right? And then that will be 5 pi over 6. If you have 1 rotation, you're adding pi, which is 6 over 6, plus 4 pi, so it will be 10 pi over 6. And then adding 6 over 6, you get 11 pi over 6. Let's reduce if you can. This second one you cannot reduce. The third one you can reduce, which is 5 pi over 3. Fourth one will be still 11 pi over 6. And that should be the angle. What about C? You see 3 theta. So let's find 3 theta value first by isolating or get rid of everything else. So first you're going to add square root of 2 both sides. And then I guess you need to divide both sides by 2. So you get cosine 3 theta is equals to square root of 2 over 2. And when we know this is going to be the same as, this is rationalized value, so that will be the same as 1 over square root of 2, right? And when you multiply both sides by inverse cosine, you get 3 theta is equals to cosine inverse of 1 over square root of 2 value. And which one gives you cosine 1 over square root of 2? That will be 45 degrees. We wanted to talk about degree this time. So that will be 45 degree positive. Positive cosine is going to be x being positive. So all this is x positive. So it will be first quadrant and fourth quadrant. First quadrant is going to be 45 degrees and plus 360K. And fourth quadrant will be 360 minus 45. So it will be 315 degrees plus 360K. And when you divide both sides by 3, you get theta is equals to 3 goes into 45, 15 times, plus 120K. And you get 315 divided by 3, you get 105 plus 120K. Let's figure out how many angles you can find with these 2 equations within 1 unit circle. So the first one will be 15 when k is 0. Second one will be 105 when k is 0. And this is all degree. And when this k is 1, it will be 120 plus 15. So that will be 135. 120 plus 105, that's 225. 240 times 15, so it'll be 255. And that gives you 345. That will be all the angle within 1 unit circle that satisfy these equations. Let's look at the next one. This one, let's see what we wanted to do. Again, let's isolate this part, right? It means you're going to add 3 and then divide by 5. So when you add 3, it will be 5 cosecant theta equals to 5. When you divide that by 5, it will be 1. When you do the flipping, so trying to change the given trig into sine, cosine, tangent, we know this is inverse of sine, so this is going to be same as having 1 over sine theta equals to 1, because 1 over 1 flip is still 1, right? And then when you flip this, that will be still 1. So if you wanted to solve for theta by multiplying both sides by sine inverse, the angle is going to be pi over 2. How do we know that? Well, the only angles it gives you sine, which is y value 1, is this point right here. That point gives you x value 0, y value 1, which is going to be pi over 2. So pi over 2 plus 2 pi k. But again, they wanted to find the solution within 1 unit circle, so that will be, just pi over 2. Let's try cotangent this time. So I will subtract 1 first, trying to isolate my trig functions. Right, that's what I will start with, and divide everything by square root of 3. I get cotangent theta is equals to negative 1 over square root of 3. But again, we are more familiar with sine, cosine, tangent. So if we can rewrite this into tangent, that will be easier. And by rewriting cotangent to tangent, you wanted to flip the value also. So it will be square root of 3 over 1, right? And that's negative 3. In order to find the theta now, we're going to multiply both sides by tangent inverse. And which angle gives you tangent square root of 3 over 1? That's going to be 60 degree. 60 degree. Tangent, when is the tangent negative? This is positive, positive. This is negative, positive. Negative, negative, and positive, negative. Your tangent is negative in these 2 quadrants, right? So it will be 60 degree in the second quadrant and fourth quadrant, which means 180 minus 60 for the second quadrant. For the fourth quadrant will be 360 minus 60 degree. That gives you 120 degree and 300 degree. Within 1 unit circle, that should be your solutions. What about if you have more than 1 trig functions? Well, here you have one here with the square. You have another cosine without the square. The easy way of doing this is using the factoring method on these problems. So look like you have a common factor of cosine x. When you factor from these two terms, you get cosine, 1 cosine remains, and this is going to have 1. Once you factor it, you're going to let each factor equals to 0. So this equals to 0, and this factor equals to 0. And solve for each. So this means you're looking for value or angle where cosine inverse is going to be 0, right? When is the cosine 0? When is the x 0? So when is the x 0? X 0 in that 2 point, right? That will be pi over 2, and that will be 3 pi over 2. And this one, you're going to add both sides by 1. So this is asking when cosine, what angle, right, is going to give you a value of 1. We know that's going to be when is x equals to 1. This is when x equals to 1, right? Which is starting from 0, so it'll be 0 and pi. Wait, hold on. That's not going to be 1. That's going to be negative 1. Negative 1, 0, and this is 1. So that will be just this point, right? So it will be 0. So the solution will be 0, pi over 2, 3 pi over 2. Problem B, we have 2 cosine square x plus cosine x minus 1 equals to 0. Because you have two different of the cosine with x value, one with the square, one without the square, you know that you're going to factor somehow. And you should be recognizing this is going to be similar to trinomial in quadratic. So if we have 2x squared plus x minus 1, the way that you're going to factor this is going to be 2x minus 1 and x plus 1. So because you have 3 terms here, you have 3 terms. 2, 3, and this 2 is double, and the third term is constant, no variable, no variable, which is going to be same format of quadratic equation. So when you factor this, you should be able to use this factoring trinomial method. So you end up getting 2 cosine x minus 1 and cosine x plus 1. So here you have an x. When you're factoring quadratic into linear, this x comes from the middle term, right? So this middle term is where you're going to use for the factoring on both factor, right? So that's how you're going to factor these problems. Once its factor equals to 0, you're going to let each factor equals to 0 and solve them separately. When you add 1 to isolate cosine x by itself, you have 2 cosine x equals to 1, and you divide both sides by 2, you get cosine x equals to 1/2. What does this mean? It means what angle give you a value of 1/2. So you should be able to write that as x equals to cosine inverse of 1/2, right? This is what they're asking. Which angle give you 1/2 value? And you know that that's going to be 60 degree. 60 degree, but also we know that cosine is positive in a first quadrant, but cosine is also positive on a fourth quadrant. So because you have positive 1/2, you have one more angle of the possibilities, which will be 360 minus 60. So that gives you 300. And the other one, you subtract 1 from the both sides of equations. You get cosine x equals to -1. This means which angle give you value of -1? Which angle? So cosine is x value. When x value is -1 is this point right here, which is on the 180 degree, right? This gives you -1, 0. So your x is going to be equals to 180 degree. So the solution of this problem could be either 60, 180, and 300 degree. Then if we're looking at the problem C, this time you have 4 terms. 1, 2, 3, 4 terms. And 4 term, if you're trying to factor, you can only use common factor or group factoring, right? So look like you don't have common factor throughout the 4 terms, so you're going to use the group factor. First 2 versus last 2. From the first 2, common factor is tangent square x. Then you will get tangent x minus 1 remains. From the last 2, if you factor -3 out, you will also get tangent x minus 1 remains. And from these 2 terms, look like tangent x minus 1 is common, so when you factor that, you get tangent square x minus 3 remains. Once you have factor form equals to 0, solve each factor separately. So the first factor will give you tangent x equals to +1. Again, this is asking which angle give you value of 1, right? So you could rewrite this as tangent inverse give you -1. And which tangent give you -1? That's going to be 45 degree, but they want you to answer it in the radians. So it will be pi over 4. So this is going to be pi over 4, and this is positive. Let's think about which quadrant tangent is going to be positive. It will be only first quadrant, and third quadrant your tangent is positive. So we need to find one more value that's equivalent to pi over 4 in a third quadrant. That's going to give you pi plus pi over 4. So that makes it 5 pi over 4. Let's work on the other ones. So tangent square x minus 3 equals to 0. And when you isolate tangent by itself, you get equals to 3. When you square root each side to get rid of square, you get plus minus square root of 3. So this means which angle gets the value of plus minus 3 in tangent values, right? So plus minus means you need to find all the angle from all 4 quadrants, right? Because remember, tangent is positive in first and third, which is the positive value, but tangent is negative in this 2. So you need to find all the value from all 4 quadrants. And which angle give you tangent value plus minus square root of 3? That's going to be 60 degree, which is pi over 3. So pi over 3 in a second quadrant will be pi minus, so let me draw that here, it will be pi minus pi over 3. That gives you 3 minus 1, so it will be 2 pi over 3. This is pi plus pi over 3, so that gives you 4 pi over 3. This is going to be 2 pi minus pi over 3. So 6 will be 5 pi over 3. So all the angle is going to be here and here. And that gives you pi over 4, 5 pi over 4, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Will be the solution of that problem. And if we're looking at the next one, this problem, you wanted to start by putting everything in one side of equation. So once you factor it, you will have factor equals to 0. It means you're going to subtract both sides by 2 sine x. And then you see that you have common factor sign. So when you factor sine x, you get cosine square x minus 2 remains. Let the each factor equals to 0. You get sine x equals to 0 and cosine square x minus 2 equals to 0. So sine x equals to 0 means which angle gives you the sine, which angle, right? Which angle give you sine value 0? So that's going to be 0 and 180 degree. Sine value 0 means you need to assume that you be able to find the y value 0, right? That's how y value 0 will be this 2, right? That's 0 degree and 180 degree. So that's the solution. This side, you add both sides by 2 and you square root that to get rid of square. And this one will have no solutions. How do we know that? What's the square root of 2? This is about plus minus 1.41 ... right? Which is outside of the cosine domain. So on this one, you have no solutions. So example 4 problems, we are still solving, but difference in these groups, you have different trig functions. Before, you have all same once you factor it. Here, you have completely different ones and where you cannot factor it, right? To make it different problems. So in this case, we're going to use identity to get the same trig functions. So if we're looking at, this should be problem A, right? This first problems, we have 2 cosine square x plus 3 sine x equals to 0. So what do I know? Whenever you have a square of either sine and cosine, we can use the identity to convert that into the other ones. And we know that cosine square x, it should be equals to 1 minus sine square x. Again, I'm using identities. So this can rewrite, this cosine square x can be rewrite as 1 minus sine square x. And then we have 3 sine x. And you open the parenthesis by distributing. you end up getting 2 minus 2 sine square x plus 3 sine x. Then let's rewrite this in descending order and make the first term positive. So it means you're going to multiply everything by negative. Then it gives you 2 sine square x minus 3 sine x minus 2. So again, in order to make this square in a first and make this negative positive, you multiply everything by negative and make it descending order, right? And then when you factor this, because this is look like quadratic, right? So this is similar to 2x squared minus 3 minus 2. And when you factor this, you get x minus 2 and 2x plus 1. It means when you factor this trig functions, you will get sine x minus 2 and 2 sine x plus 1. Same factoring as this, it's just that instead of x, oh, that should be x right there, right? Instead of midterm x, your midterm on this trig function is sine x, right? That's what you have this here. And then once you have that factor equals to 0, let each factor equals to 0 and solve them separately. When you add both sides by 2, this is asking which angle give you sine value 2, right? I'm trying to write and think at the same times. And this is going to be no solutions, right? Why is that no solutions? Sine domain should be between negative 1 and 1. This is outside of the domain. So that's why it's the no solution for that factor. This factor, when you subtract 1 and divide by 2, you get sine x equals to negative 1/2. So which angle give you sine value negative 1/2? That's going to be, sine value 1/2 is going to be pi over 6, right? And this had to be negative, and pi over 6 negative. And sine negative, in which quadrant? Sine is negative in this quadrant. Y is negative in third quadrants and fourth quadrants. So pi over 6 in third quadrant should be 7 pi over 6. Pi over 6 in the fourth quadrant is 2 pi minus pi over 6, so that makes it 11 pi over 6. So that will be the solution. This problem B, you will see different trig functions again in one equations, but this one is double angle. So use the double angles to change cosine into sine. Then you will get this right here become 1 minus 2 sine square x, right? Using the double angle formula. And then you have plus 3 sine x minus 2 equals to 0. And you can combine these two to make it negative 1, right? And what else you need to do? Make the leading coefficient positive. So you're going to multiply everything by negative. Gives you positive 2 sine square x minus 3 sine x and plus 1 equals to 0. And when you factor this, you get 2 sine x minus 1 and sine x minus 1 equals to 0. Again, if you don't see how I got that, trying to use the substitution method. So this is going to be identical form of 2x squared minus 3x plus 1 in a quadratic form. So when you factor this, you get 2x minus 1 and x minus 1. So use that to get this factor. This factor, that factor is identical. Difference is this is x, this is going to be sine. So once you do that, let each factor equals to 0. And when you solve for x, this you get positive 1/2, this you get positive 1. This means which angle give you sine value 1/2, right? Sine is y value. And that's going to be pi over 6 positive. This is positive, right? So that's why it's positive. And pi over 6 positive is on the sign is going to be, remember sign positive is, well, that was sign negative, so sign positive will be here, right? This is sign positive, and this is sign negative, right? So it will be second quadrant and first quadrant. First quadrant means just pi over 6. Second quadrant is going to be pi minus pi over 6, so it will be 5 pi over 6. And this one right here means which angle you get sine value 1, right? Sine is y value, so that will be 90 degrees, which is pi over 2. So that will be the solutions. This was long sections, and this is the last problem. You have sine x times cosine x equals to 1/2. Let's try to get rid of 1/2 by multiplying both sides by 2. You get 2 sine x cosine x equals to 1. The reason I did that is because this is very familiar. What kind of formula you see this? Double angle formula. This is one of the double angle formulas. And that is equals to sine 2x equals to 1. So this double angle formula become this, right? So when you have sine 2x equals to 1, you multiply both sides by sine inverse, so you can get rid of sine. Then you get 2x equals to sine inverse of 1. So this means which double angle of sine value is 1, right? And then this gives you 2x equals 2. That will be another pi over 2, right? Y value 1 is pi over 2. Again, this is y value 1, 0 and 1. And when you divide both sides by 2, to get rid of this 2, you need to make sure this is, you have more rotations added before you divide. And when you divide by 2, you divide everything by 2. So you get pi over 4 plus pi k, right? Let me show you. Divide by 2, divide by 2, and divide by 2. Okay, that's what you get. And when you calculate that for exact, it will be pi over 4. And add one more rotation pi. That gives you 5 pi over 4. And that will be the solutions within one circle.